we're live. We're here with team 7. So as I mentioned, the rule, you have 8 minutes. Okay. So, and I will announce you when you have 1 minute left. Okay. So I
Okay.
will set the timer. Just give me a second. Okay. Let's get to it.
Okay, hello everybody. Our topic is about deep learning approaches for brain-to-speech, or in other words, inner talk synthesis, inner talk translation, speech to text or to the languages. And for understanding better, I'm going to introduce a very famous person with name of Stephen Hopkins, which is a very good intuitive for us, or very good inspiration for us to understanding how is it works. So actually, Stephen Hopkins started talking with other person without talking with other person. It was suffering kind of disease like lichen syndrome, and he was using P300 and eye tracker to talk with other person without talking. So it is very good motivation for us to start working in this field. So for the first things, for the first side, we are going to use this subject to how to other persons, some persons to suffering kind of disease like Swen Hopkins, like this syndrome, dysphasia, those persons who cannot talk very easily. And for the second side, we are going to use this subject to those persons which can talk, but not they don't want to talk. For example, when some persons are at downside of the water and they want to talk with other person, but they cannot talk at downside of the water. Or imagine about other situation when a person or in a are going to use this subject to like this syndrome, dysphasia, those persons who cannot talk very easily. And for the second side, they're going to use this subject to those persons which can talk, but not they don't want to talk. For example, when some persons are at downside of the water and they want to talk with other person, but they cannot talk at downside of the water. Or imagine about other situation when a person or in a conferences or in a symposium or something like that, and a speaker is talking, and you want to talk with a person next to you, or your call start ringing, and you want to talk with other persons. So it's kind of impolite things which a speaker is talking and you want to talk with other persons. So in this situation, you can talk with other persons without talking with inner talk, just that with the inner talk. And when we are talking about speech, and when we are talking about AI, it reminds us is a kind of interdisciplinary field. And so in these things about speech, we are going to mix AI with the neuroscience and cognitive science. So it's a good motivation for us to go inside of these things, and for talking with other persons, share our information. Speech or talking is a very good for things or way for interact with other persons. So the speech is so important. So for understanding the inner talk, inner speech, we are going to design our work here in two ways. For the first way, we are going to talk about our architecture. We are using the autoencoder network with the architecture of convolutional neural network, which map the inner talk speech to the words, and then with a synthesized speech model to condition the generated languages from the sequence of words, and then use the gradient-based localization map to understand which part of the signal is so important for our new age. And this kind of architecture is an interpretable architecture to reveal the new age that how brain work for different situation. And also for another side, we are going to design, we're going to consider our task design, especially, for example, other scientists, they just wanted to gather data from the brain, and they just wanted to say to other person, okay, sit here and we're going to gather data. But they didn't consider that there is a kind of place of articulation inside of your mouth when you want to talk. For example, for the different vowels, when you say a or u, there is a fall distance. If you consider this place of articulation inside of your data, or if you consider those parts of your brain inside your brain, like fusiform face area, hippocampal face area, which also important to react to other things outside of the words. We can consider these things inside of this speech to discriminate words after recording the data. So for doing this, I'm going to talk about a very famous project in this topic. They just started the project in the University of California, supported by DARPA and the President of Obama. And they wanted to understand how we can understand speech from the brain. And also some other scientists, they just wanted to understand the speech from some stuff like fMRI and some person imagine, for example, a dog after they just saw a dog on top of the monitor, and imagine the dog and take a fMRI and then understand from this image if was it dog or not. So already we have a kind of data set, which even EEG and fMRI and other stuff, but we are going to seek a kind of very big and usable and possible data set with the EEG, which because EEG is not invasive, and EEG also is a more cheapest, and if we are going to use EEG with lower channels, we can use it everywhere. So, and also we are going to seek if the data set comes from the different sexuality, like the patterns which produced by the brain from the male and female, are they different or not, or from abnormal persons or normal person, are they different or not. So this project will be impact at the first for the way of interact persons for the future. For example, can you imagine how they can talk with other persons even without talking? And also we can help the persons, those are suffering kind of abnormal things, to interact with other person. They would be very happy. So yeah, I have to say that it would be very possible, because if it accessible to kind of some laboratory with different scientists of different subjects, and we have access to that data set, and we can record it to that laboratory. We will support with those things. We can do this project, fortunately. About our teams, I have to say that I am so delighted that these teams, I know them with the same similar like me, Daniela, and Shiraj. We have in the same favorite things in the back work with the EEG teams, EEG staff in the field of neuroscience, and we have same favorite things for the future for understanding speech from the brain. And also Robert and Sebastian, they work with the autoencoder generating models, which we are going to use in our dataset. I have to tell that Sebastian and Robert, Sebastian,
1 minute left.
Okay, Sebastian came from the Poland, Robert and Daniela from the Romania, and Shiraj from India, and I'm working in studying PhD in Hungary, but I'm originally from Iran. So at the end, I have to thank all of the organizers for the EEML Summer School and my teammate to make this presentation. And I have to tell you that speech is so important for the field of AI. Thank you.
Okay, thank you very much. So we still have like 15 seconds. Maybe each of you can say hi, at least. Unmute yourself and say hi now.
Hi.
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 Okay, great. Thank you for that.
Don't forget to vote us.
For all the listeners, if you've enjoyed this project, this is a project that you feel like you would like to work on, please vote for this project. So this is team number 7.